Hi geometers, on this lovely day what we're going to do is we're going to prove and use results about parallel lines and something called transversal. Now in our previous lesson we already talked about transversals. Transversals, yeah. Alright, so we are, first off, one thing we're going to look at is that these two lines here are parallel, so let's go ahead and mark that as parallel. And we're going to walk through a few different theorems and postulates about things that are related in this. Now, we've already talked about how this family of numbers or angles are related. Well, clearly we know that these two are a linear pair, therefore supplementary. 2 and 4 are vertical angles, therefore congruent. And the same goes on for everything up here has a relationship with another. Well, it turns out that the relationships from one category, like this family up here to this family down here, 1 and 5 have a relationship. We call that corresponding angles. Well, if I had to take a guess as to this angle right here, how it compares to the measure of this angle down here, angle 5, we would say, well, they're both acute, so they're probably congruent. Well, if you actually did the measurement, you would find out that, according to the corresponding angle postulate, if two parallel lines are cut by a transversal, then corresponding angles are congruent. Now, it is called a postulate because one of these, and it actually doesn't matter which one that we're using, one of them has to be a postulate because there is no theorem or definition or anything that we have thus far that connects this down to here. We have supplementary and linear and all that connects up here. All these down here are connected to each other, but not from one to another. So one of the assumptions have to be made that corresponding angles are congruent. So that's where we will start. According to this diagram, we can conclude a number of things, but we can say angle 1 is congruent to angle 5. There are 3 other pairs that you can say, but we'll just stop there. Well, if we were to go on and look at alternate interior angles, so if I rotate here and look, alternate interior, what do they alternate? So here's the transversal, so take this angle, and it's got to alternate sides, but then it's also inside. Well, since 3 and 4 already have a relationship, we're going to look at 4 and 6, and that's obtuse, that's obtuse. So if I had to take a guess, I would say that alternate interior angles are also congruent when we have parallel lines. So in this case, angle 4 is congruent to angle 6, and there is another pair up there as well. So let's just continue. Alternate exterior angles theorem is going to say almost the exact same thing. If two parallel lines are cut by a transversal, then alternate exterior angles are congruent. And in the diagram here, a pair of exterior angles would be 1 and 7. And they're exterior, so outside here and outside here. In other words, outside these two lines. And they alternate the transversal. So 1 and 7. There is another pair. So angle 1 is congruent to angle 7. Now, consecutive interior angles would be something like this, 4 and 5. These two here are consecutive interior, as are 3 and 6. Well, notice that this one here is obtuse. This one here is acute. And it would make perfect sense that those two would be supplementary. So consecutive interior angles are supplementary when we have two parallel lines. Well, it turns out, and although many books would not actually have this theorem, we can come up with our own theorem here, that it turns out consecutive exterior angles are also supplementary. So let's look at my diagram for a pair of supplementary interior, consecutive interior, so 4 and 5, and then for the exterior, 1 and 8. So how do we write that? I can say angle 4 and angle 5 are supplementary. Now, practically speaking, oftentimes we're going to want to solve for a variable, so we can actually jump straight to an equation by using the definition of supplementary, and that says that the two measures add up to 180. And that same thing goes below. And there you go here. Well, now that we have all that, now we can start setting. So looking at the next page here, problem number 1. All we have to do is first off, we notice that I have parallel lines, so all of these theorems apply, or postulates. And then I surmise, well, how are these two angles related? Turns out they are corresponding. So because I have parallel lines, corresponding angles have to be congruent. So I don't simply say corresponding angles. I have to start with parallel lines, therefore corresponding angles are congruent. So that means the measure of angle 1 is equal to 118 degrees. And if you wanted to continue on, you notice here that these are either, you can state them as vertical, these two are vertical angles, or you could say that these two here are alternate exterior angles. So let's just go with that, since that's in the chapter we are, the section we are. So alternate exterior angles are congruent because the parallel lines. And there we go. So that means the measure of angle 2 is also 118 degrees. All right, let's complicate things a little bit by looking at, say, something like number 9. Again, our first observation is that the lines are parallel. Since the lines are parallel, we now know that any of the theorems or postulates apply. So I think about this angle here and this angle here. They are consecutive interior. So because of that, parallel lines, consecutive interior angles are supplementary. So I'm actually going to jump to the formula which says this: 75 when added to 4x minus 9 is going to give you 180. So then we can begin solving, combine like terms to get 66, subtract 66 to get 114, then divide by 4 to get a fraction, and my answer, 28.5. Notice I'm only asked to find the value of x. I don't have to go back in and find out this right here. But we already knew that because those two were supplementary. Now take a moment to practice these problems and make sure that you get them correct. We're going to look at a proof, because proof, being able to accept one thing because I say so, is nice and all. However, what we're going to use is the law of syllogism. We're going to start here and we're going to conclude here. And notice there's going to be a couple steps in between. So first thing I'm given is that those two lines are parallel. So that's a great place to start. Since I have lines that are parallel, I can state that. So that's given information. Now notice, since I'm asked to prove the alternate exterior angles theorem, I cannot say, oh, angle 1 and 2 are congruent by alternate exterior angles theorem. That's like saying, what does the word masticate mean? And you say, oh, masticate means when you are masticating. And of course, that doesn't help because I'm using the word to define the word. Masticate means to chew. So in the same way, I can't prove this theorem by using this theorem. So let me use something else. Well, I do know that angles 1 and 3 are congruent because of corresponding angles postulate. So angle 1 is congruent to angle 3. And I'm going to actually summarize rather than write the title. I'm going to say parallel lines cut by a transversal, corresponding angles are congruent. Looking at my diagram, I also see that angles 2 and 3 are vertical, so therefore angles 2 and 3 are congruent by the theorem that states vertical angles are congruent. And lastly, since angle 1 is congruent to angle 3 and angle 3 is congruent to angle 2, we can connect the two, angle 1 and angle 2. And why can we connect them? The transitive property of congruence. And there we have it.